Guys, and welcome back to my channel. In this video we are going to be looking at types of vectors. Okay, I'm George Boma Smith. Okay, so when we talk about types of vectors, I'm going to be considering just those common types of vectors we always encounter. Okay, they are very common, and those are ones we are going to look at in this video. So the first type of vector we are going to be looking at is what you call the zero vector. Now another name for the zero vector is a null vector. And what that simply means is that this is a vector with a magnitude of 0, with a 0 magnitude. Okay, this is what it means. Generally, we have vectors. A vector could have an initial point to be P, and then a terminal point to be Q. But there's this possibility that the initial and the terminal point will coincide. When initial and terminal point coincides, that vector is called a null vector. So just imagine that in place of P, you have something like this. So you have A from point A down to point A. For the fact that the starting point and the end point are the same thing, this is what you call a null vector. So usually, instead of us to represent null vectors in this form, this is how we represent a null vector. We just say it is a 0. Okay, then we have the arrow overhead. So you have a 0 and then the arrow overhead. This is how generally we represent null or zero vectors. So a null vector, since it has no magnitude, it can take basically any direction. The representation of it is just you having a point that can take any direction. So the direction doesn't really matter because it is a zero vector. Okay, so in general we are saying if we have a vector A or a vector P, then this vector is going to be a null vector if the magnitude of P, this is the symbol we use for magnitude, just two pipe symbol, and then we have the vector across it. If the magnitude of P is equal to 0, then it's called a 0 or a null vector. Okay, we are going to talk about magnitude of vectors in videos to come so that you better understand what we mean by the magnitude of vectors. So next we have the unit vector. What we mean by a unit vector is simply a vector with a magnitude of 1. So if I have this vector, the unit vector generally can be represented as A with a cap. Okay, so if this is a unit vector, this A cap I have here, for the fact that I use cap, it means it's a unit vector. For the fact that it's a unit vector, it means if I look for the magnitude of A, then I should be getting my result as 1. So like I said, we are going to look at what we mean by the magnitude in later videos. But this is what you call the unit vector. So take note, this is said to be the unit vector in the direction of A. So if I have a vector like Q, the unit vector in the direction of Q can be expressed as Q with a cap. That's the unit vector in the direction of Q. So whenever a vector is having a cap overhead, it's referred to as the unit vector. Now, we are going to be using 3 basic unit vectors. They are the unit vectors in the x-axis, the y-axis, and the z-axis. Just imagine you have the coordinates, the Cartesian coordinate plane, okay? And then you have this x, y, and z. This is assumed to be the x plane, this is the y plane, and this is the z plane. So this is the y plane, the x plane, and the z plane, the z-axis, x-axis, y-axis, z-axis. Now, there's a unit vector that is always in the x-axis. What we use to represent that unit vector is I cap, but usually what you see is I dot. There's also a unit vector in the y-axis. What we use for that is j cap, but usually what you see is just j. Okay, and what we use for unit vector in the z-axis, we use k cap, but usually what you see is just k. It doesn't matter, just know that k is for the z-axis, I is for the x-axis, and j is for the y-axis. These are what you call unit vectors in the x, y, and z-axis respectively. Okay, so next we have what we call the co-initial vectors. When you talk about co-initial vectors, they are vectors that have the same starting point, the same origin. So you can say I have this vector AB, the origin is A. I have another vector AC, the origin is A. When vectors have the same origin, you call them co-initial vectors. Another we have are what you call equivalent vectors. Now generally when you talk about equivalent vectors, they are vectors having equal magnitudes. Okay, they may not be equal in values, but they have equal magnitude. So that means I'm saying if I have a vector A and a vector B, that these two vectors, they are going to be equivalent vectors if the magnitude of A is actually equal to the magnitude of B. So once they have the same magnitude, we call them equivalent vectors. Next to equivalent vectors are what we call equal vectors. Vectors are said to be equal if they are equal in all respects except their starting point. They may not start at the same point, but they have the same magnitude and they have the same direction. So equal vectors are vectors that have the same magnitude and the same direction. So these two vectors are said to be equal because they have the same magnitude, they have the same direction. And once vectors are equal, you just say A is equal to B, and that is it. Okay, so you can see that they may not have the same starting point, but their directions are the same thing and their magnitudes are also the same thing. When we come to the component, you see that for equal vectors, they must have equal component also. Okay, next we have what you call negative vectors. Now if I have a vector like this, then the negative of this vector is going to be this. Now negative vectors are also called equivalent vectors because they must have equal magnitude for the fact that they are negative vectors. Okay, so A and AB and minus AB are negative vectors. That means if one is going this way, then the other one will be coming this way, but they will basically have the same magnitude, but in this case they have directly opposite direction. Okay, so that's what we have for the basic types of vectors we are going to be looking at. Okay, so that's it for this video. In the next video, what we are going to be looking at are general representation of vectors, how we can represent vectors in terms of the unit vector we just discussed here. Okay, so if you have any question, go ahead and put it in the comment section below. Reach out to me and ask your questions. As usual, make sure you like and subscribe to my channel. I'll see you guys in the next video. Bye bye.